parts. I did that on purpose because I figured it was probably good to see it, really look at it closely, not go too fast, and then take a day, like take an evening, relax, come back, see it again as a class. Because I'm hoping that when you see it now, things will start to click. And it worked for the other group, and I think it'll work for you guys. We did this with we did this at some point in here already, and I remember you guys really responded well to it. The only problem is it takes up a lot of time to be able to review something half and half like that. But we have a little bit of time since we delayed this unit already. So, we got this. Question is, sketch the graph of this thing. And you look at it and you go, never sketched that in my life, no idea where to start. But you're a wise individual and you go, hey, I can graph that thing. And so you do. You look at that, you have two x-intercepts. Where are they? 2 and -2. So you're like, hey, that graph's got 2 x-intercepts. Beautiful. Now, if you could find the y-intercept, you would have a beautiful graph where you can just connect all the dots and it's over. Your y-intercept happens when you're in this form. So you can just FOIL and get right into that form. Right? So FOIL that out and you get x squared plus 4.
Minus 4.
Yes, minus 4. Thank you. Yeah, my bad. So you get x squared minus 4. That right there, that's your y-intercept. So you can come down here and graph your y-intercept. Your y-intercept, it's at minus 4. Now you've got a graph you can do. So connect the dots. Look something like that.
Beautiful.
Beautiful. Once you have that, you're able to graph the reciprocal of a graph. So we could take that and graph the reciprocal of that, which is what the question is actually asking. To graph your reciprocal. So we're going to now change that into what we actually want it to be. There's 3 steps. What's the first step? Asymptote. There's one asymptote that always exists in our class all the time. Which one is that? The x-intercept. This one always exists. It's always there. Now, there's other x-intercepts. And when do they happen? Sorry, we're not on step 2 yet. I just mixed up my words there. There's other asymptotes. Where are they? Yo, they're at your what, though? What are those called? They're at your x-intercepts. So if you look at your x-intercept, it's right there. That is a vertical asymptote. And you have another one over here. Now that you've drawn all your asymptotes, you need to do your second step, which is what Keeley said. And it's what, Keeley? Your invariant points. Your invariant points are the points that won't change from either graph. So they're going to be the same on both graphs. When do they happen? They always happen when y is equal to 1. They always happen when y is equal to -1. Y is equal to 1 right here. There's 2 spots. One there, one there. Y is equal to -1 in 2 spots. Right here and right here. Okay.
So it's always like on the graph.
It's always on the graph where y equals 1 or -1. Yeah. And the reason for that is when you reciprocate 1, you get 1. When you reciprocate -1, you get -1. They don't move. Now your third step is to reciprocate. Which, I don't know if that's really a word or not. That's what we talked about.
It is.
But it is. Did you Google it? Oh boy. Ask Jeeves. So some people are like, hey, I remember that solid reference from yesterday. And other people are like, whoa, we had school yesterday? Okay. You're going to reciprocate. The first point you're going to reciprocate is your max or your min. But before we do that, I'm going to go off on a little bit of a tangent and try to discuss how you reciprocate in another way. So we're going to talk about this in another way. Yeah, and that's what I'm going to now show you in a new way. Your asymptotes have cut your graph up into 6 pieces. Does everybody see it? There's a zone here, a zone here, a zone here, another one, another one. 6 chunks. There's 6 chunks to your graph. I'm going to label them 1, 2, 3, 4, 5. You don't have to write this down. You don't have to label them. I'm just trying to demonstrate this. See how there's 6 chunks to my graph now? We're going to go chunk by chunk. And we're going to reciprocate chunk by chunk. Now the thing is, asymptotes contain things. They're like a fence, right? So whatever's in this chunk has to stay in that chunk. Whatever's in that first section can't leave that section. So when we reciprocate it, it's got to stay in that section. So we look at section 1. We've got a green line that runs like that. To reciprocate that, you're going to start along one of your asymptotes. Remember, you run right beside the asymptote until you get to your invariant point, and then you switch and you start going towards the other asymptote. That's the reciprocal of that section. If you look at the second section, is there any green in that second section? No, so nothing can come into that section either. There's nothing in there to reciprocate, and there's nothing going to appear in there either. So that section's going to remain blank.
Will that always?
It'll always happen. That's what asymptotes have done. They've isolated this graph off into sections. They've cut it up. If we look at the third section, there's a chunk in there that we can reciprocate. This little green line in the third section, we need to reciprocate it. You can start at either asymptote. I'm going to start up here. I'm going to run along the asymptote until I get to my invariant point. And then I'm going to start to bend and switch to the other asymptote. That's the reciprocal of that green chunk in section 3. If I look in section 4, is there anything to reciprocate in section 4? No, so nothing should appear in section 4 either. If I look in section 5, is there something to reciprocate? Yes, and the key to this one is there's a maximum point. So we need to reciprocate that maximum or that minimum point first. To do that, you go to your max or your min. We have a minimum or a maximum. We have a minimum point. You take that value. That minimum is at 4. When you reciprocate 4, what does it become? 1 over 4. So this point moves all the way up to 1/4. Right there. The reason we do that first is because that's where you're going to start reciprocating. You're going to start there. You're going to run along the side of your asymptote until you get to an invariant point. Then you're going to run along the other side of the asymptote. And then you're going to do the same thing the other way. Run along the asymptote, hit your invariant point, run along your asymptote. Time. Yeah, it would be -4, it would be -1/4. Section 6, is there anything that we need to reciprocate? No, there's not. So we're done. Your blue graph, that's your reciprocal function. That's this entire thing. Weird, right? How are we feeling about this compared to yesterday? Make a little bit of sense? It's like looking at it like, oh yeah, that kind of parts of it are coming together. For people who weren't understand reciprocating, just chunking it out like that makes sense. Does that help? Yeah? Okay, making it like plots of land, basically. Alright. I've never tried that before, so I'm seeing if it is helping. It made it worse or better?
Better.
Yeah. Let's try another one. So, sketch this graph. You look at that graph and you go, I don't know how to sketch that. And that's fine, because nobody knows how to sketch that. But what we do know how to sketch is that. What's up, Zucker?
So, example, if it was x minus 1 and then in brackets x minus 2, it would be the x-intercept would be 1 and 2, right?
Yeah.
Okay, so it's whatever time it's 0.
Exactly. So whatever makes it 0. So, we've got x-intercepts here. What are my x-intercepts? Negative 1 and 1. Now I need another intercept. I need a y-intercept would be really nice. Real nice. Foil it out, but then there's going to be a little trick to this one. So we're going to foil that out, and you're going to get minus x squared minus 1, like that. Yeah, it'd be positive 1. That negative has to come into the brackets as well. So it's negative x squared plus 1. Cut. Yeah, I see what you're saying. When we had to reverse the two things, yeah, that's basically what they've done.
Okay.
They've taken the negative 1 out. Yeah, good connection. That's what you're saying. That's exactly what they did.
Okay.
That gives you your y-intercept. Where's your y-intercept? It's at 1. Right here. Now you can draw your graph. Ooh, I missed it. The thing with these graphs is you don't have to be perfect, but certain parts have to be perfect. You want to make sure you hit your x-intercepts right. You want to make sure you draw your asymptotes on the right line. And you want to make sure that you get your invariant points in the right spot. Everything else, for the most part, can really be a little bit off and you're good. But who was Hunter? Were you? Yeah. It was you and me who were doing asymptote earlier today, right? And your asymptote was a little off the line. It can really make your life hard if your asymptote's a little bit off to the side, because it could really mess with something. So there's a few important lines to make sure you're getting right. The x-intercepts are important, and the asymptotes are important. Okay, so we've drawn this. It looks so good. Now we have that. We're like, we can reciprocate that. What's your first step to reciprocating a graph? Asymptotes. Your asymptotes are where on a graph? They're your x-intercepts. Can you grab the door for me, please? Okay. Your first step to reciprocating this graph is to do what? Asymptotes. Where do your asymptotes occur on a graph? Your x-intercepts, and there's one other one. And your asymptotes are, this is how I started picturing them now. They're fences. They're fences. They've broken off things. So in this area, whatever's in this area has to stay in that area. Siege, put it away. So whatever you have in that area has to stay in that area. What's in this first area up in top of the corner? Nothing. So you don't have to reciprocate anything. And I've actually skipped a step.
Invariant points. Get it together, man.
Invariant points.
Get it together.
Well, there's a reason I did skip that too. Because where do your invariant points happen? Where y is 1 and y is negative 1. Let's do our negative ones first. Where y is negative 1. Right here, right here. Where y is positive 1. Okay, I'll take the mask if you guys can't find it. Well, clearly not, because Ploggadog's face is so red that you think it's strawberry. Where y is positive 1 is also a pretty important point. It's a maximum point. So that's going to do something weird for us when we come back to do this other question. Okay. Step 3 was to reciprocate, and I'd already started doing them. How do you Where was the desk originally? Yeah. Well, you're acting like it was there and you were stuck there and couldn't do anything about it. You literally cornered yourself as close to Pafford as you could get.
I'll sit over there and I can sit over by.
Someone really screwed with the seating today and I'm not impressed.
That's pretty funny.
Yeah,
I'm proud of whoever did it.
No, it's not funny.
Well, try getting faster with it, and you'll get your spot.
Oh,
No!
it's the machine dropped.
Yeah, they keep taking my money.
Did I tell you what happened to me on that stupid machine? I wanted a friggin' water, and it wouldn't take my toonie, so I got mad, so I was like, I got an idea. I'll put $5 in the other machine that takes bills, hit the change button, it'll give me my change, then my toonies will go in there.
Yeah.
So I put my $5 in the other machine, ate my $5. So I was $5 out in the hole and no water. I was double chapped.
Wait, did you tell the office though?
I think I just wanted to power it. It was a Sunday.
Oh.
No.
They always give me my money back.
Can't get in there, man. Sunday. It was a power day. That's what she just has too. Why would I pay for one? It was a power day.
Why were you here?
What about basketball? Shoot, I just love this place. It's just, it would be way better if there's
No,
a
the
giant
teachers,
dome.
they power them down at night, and they actually just stay in the classroom.
Oh, really?
I
Wow.
wish that was true.
How?
They just power down the teachers at night.
Okay.
Please.
Okay. So we have to reciprocate, and we looked at our first section, which was this top left spot, and there was nothing there. We then move into our middle spot, where we have a maximum point. So you always need to reciprocate the maximum first. The problem is your maximum is also an invariant point. So can you reciprocate it? You can, but it doesn't move. The reciprocal of 1 is just 1. So that point actually stays right where it is. And now, you start at that point. You start at that point, and you're going to go left, and then go up the asymptote. So you go left, you hit the asymptote, and you go up the asymptote.
The what? They hit the what? You know what I mean?
Go up
Oh,
The acid?
go up the asymptote.
Okay, don't say half.
Wait, what? Yeah, but you can't just cut it off at half. Wait, just say acid.
Shut that down.
I don't want to talk about it.
On this side, you go up the other asymptote.
It's not right.
If you're ever really confused, if you look at your graph, it should just look like it flipped, right? And that's what it did do. It just, the green part is flipped up. That's what it should look like. Hey, so if you go to your third section, is there anything to reciprocate? Fourth section, is there anything to reciprocate? Yes. So you start on one side of your asymptote, you're going to run along the side of it until you hit an invariant point, then you switch down and go down the other asymptote. If you started at the bottom and you ran up it and then through the invariant point along the other side, you get the same graph. Cut.
Like, what is that right here? It's what?
That's a good question. So, wait till everyone's listening to this one, because that's a good question. It's a very good question. Don't just put it in front of you. Actually, put it away, then you won't be so tempted. Thank you. Okay. No. Get rid of it. I'm taking it the next time I see it. It shouldn't go into that pocket again. What are these actual points? He's like, I get I get how to make them, but I don't get what numbers they actually are. And that's a really, really good question. The problem is our numbers are so small that we can't actually see them, which is why it's a little bit more difficult to picture. But we can see a couple of them. Maybe do it now. Let's take this point on the green graph right here. I'm going to estimate that that's 1/2, right? So that point right there is 1/2. What's the reciprocal of 1/2? It's 2.
Don't you mean negative 1/2?
Yes. So from 1/2, it's going to drop all the way down here to 2. And every point, as you get closer and closer, is going to go further and further down the line. Now, what makes it so crazy to picture is that you can keep zooming in. Right? You can always zoom in closer and closer and closer and see a smaller, smaller, smaller decimal. And those decimals, you got 1/2, and then you got 1/3, and then you got 1/4, and then you got 1/100, you got 1/500, and it's just going to keep happening like that forever to infinity. And when you reciprocate these numbers, they just keep getting bigger and bigger into infinity. And that's why these numbers go on forever like that. And that's why it'll go till infinity. That's why we'll never see. It'll get as close to that asymptote as possible, but never touch it. Because this bottom number will get as big as forever, but it'll never actually get to 0. It'll never be 1/something that creates 0. Not possible. And it works the other way too. So these ones are a little bit easier to picture. What's my y value right there? -3. What's the reciprocal of -3? -1/3. And that can go forever too, because we said this green line goes forever. So the highest value of x you could get, say 1 trillion. What's the reciprocal of 1 trillion? 1/1,000,000,000,000, which is a ridiculously small decimal, which is why it gets so close to that but never actually makes it. Mind blown. It does actually make sense. You can actually picture it, which is why it's kind of nice. Okay, this middle section. Is there anything in there to reciprocate? So let it be. This next section over here, is there something you need to reciprocate? Yeah. So start on one side, work your way till you hit the invariant point, then work your way on the other one. That blue function, that's your actual graph. Which is crazy, because these are harder. They're supposed to be harder. Like, they're technically harder. But it's because you've seen them over 3 days now, right? Like, we weaned into it, so it's like, this is okay. Now when you go back to the easy stuff, hopefully it's really easy. Hopefully. That was my main goal. Yeah. And it takes wonder. It's all over. Okay. Now we're going to work on the...
Why is this, when we draw the graph, it looks like that. When I graph it in the calculator, it looks completely different.
So, that's a great question. How many take John together graph your calculator right now?
Yeah, it's like right here.
Is everyone okay if I erase that? Yeah. So Dante's calculator, he graphs this. Ooh. Okay, so well, it's not your fault. The calculator just doesn't know what you're asking it to do. So when you go to graph these things, if you ever panic and put that in your calculator, which you shouldn't do, but if you do panic and put it in your calculator, you need to make sure you put the entire bottom in its own set of brackets. Otherwise, your calculator thinks 1 divided by that times that. But if you do put it in your calculator, you should get
I got exactly.
so.
Illustration is still.
Yeah, it's actually it's spot on. You should get it.
Good job, 30 guys.
You should get it without the asymptote. So if you graph that in your calculator, you're going to get just this. That's what you would get, something close to that. If you have an old calculator. So if you have a TI-83, TI-83 Plus, anybody got, yeah, if you got one of those, your graph will look like this. I don't want your graph, you don't need to pull them out.
Oh.
Your graph's going to look like this. What your old calculator does is it tries to draw the asymptotes in for you. But it doesn't do dotted lines. It does a solid line for the asymptote. Which is why your graph looks so weird. Because when you graph it, it just looks like chaos. Is what it honestly looks like. We can see this middle part because we knew it was there. But when you graph it the first time, it doesn't look good. Okay, put your calculators away. Because you don't need them for what we're about to do. So I need you to stop playing on them. Okay. You're now going to have graphs of reciprocal functions, and you're going to have to go back and graph the function it originally came from. So, we look at this, and you say, this is 1 over f of x. That graph right there. Now graph f of x. F of x is just some function. So this is the reciprocal of some function. So, right here, that's what that's saying. It's the reciprocal of some function. Then that's saying graph what that function originally was.
So you have to use the reciprocals.
Okay, we have to use the reciprocals to work our way backwards. And if anything, it's easy. Because right off the bat, you just start doing your 3 steps to reciprocate. And now we're going to do it backwards. So, what's the first step you always do? It's asymptotes. So, first step, you're still going to mark your asymptotes. But they're marked for us, right? See, it's already there. What does an asymptote tell you about the original graph? It tells you it was an x-intercept. So you're going to look at your asymptotes and mark them as x-intercepts. Your second step is going to be the same. Invariant points. Where are your invariant points always? When y is equal to -1. So here and here. Step. We can look at +1, but there's nothing up there. Right? So you're right. We have to look at +1, but there's nothing there. Now step 3 is just reciprocate, but it's going to be unreciprocated. Which really just means against your dogs. And your graph looks something like that. So it's actually a little bit easier. Josh, do you have a question still? Just wait. Josh had a question. No? You good?
So when you reciprocate, like, what number are you?
So you're taking your red numbers. You can take any number you want. We're going to take right. This is where it gets hard. because we're unreciprocating it, right? So if you took a point right here, Zocker, and that's really hard to see, it's probably going to be like 1/10 or something. What's the reciprocal of one? We'll call it a quarter. What's the reciprocal of 1/4? 4. So this point is now down here. About 4 on our original graph. And it just keeps growing down. That's where they came from. And these points in here, the ones that are closer, so like this one right here is 3, right? What's the reciprocal of 3? 1/3. So back on the original graph, it was 1/3. Amber.
Wouldn't the, like, you had to just say what it was going to be, y equals negative, bracket x minus 3 squared?
Yeah. If you had to create your graph, yes. We're not going to have to create the graph. It might pop up every once in a while, but it's not going to be a everyday thing. So we're not going to stress it. Julie?
So, like, why are we doing this? What's the why?
Does anybody remember my speech this here?
Because it all
Problem solving. Reciprocate.
Yeah, there's lots of reasons. That's that was one of my speeches. I don't like the why do we do math question. Because there's a few answers. My first answer is always my first answer is like I don't want to be here for the preach. The first answer is always you could go into university. You want to be an engineer or a math teacher, you need it. The second answer is math is meant to make your brain grow. Like it's purposely connecting neurons that make you think in a certain way. So that's the plus side of math. That's why everybody has to get taught math.
But it doesn't even seem related to what we were doing before.
Oh, you're trying to say why are we doing this compared to our rational expression?
Why is this in the same unit?
I'm picking up what you're putting down. The connections really aren't that close. The only connection you might get is the fact that your reciprocal functions are rational expressions.
Like, honestly, I don't even remember what we did.
It's a function divided by a function. And what's your question? Okay, yeah, go ahead. Okay. Let's do B. What's your first step going to be? Mark your asymptotes. What do your asymptotes tell you about the original function? It tells you your x-intercepts on your original function. So, we look at this graph. What's the problem with it, Aaron? There is no asymptote. So if there's no asymptote, what does that tell you? Not quite. It means there's no x-intercepts. So that means we're going to end up with a graph like this, or like this. Right? No x-intercepts. That's what it means we're going to get. Step 2. Just keep following the steps and it'll work out. Yeah.
Do you still draw the horizontal slope?
No, because we're unreciprocating. And our horizontal asymptote doesn't tell us anything. It does next year. But this year we only worry about the verticals. The horizontal to us is just always there.
Okay.
But it will in the future mean something.
So if you get a graph where the reciprocal is just like that little bump, it'll always be just two x-intercepts. If you get a graph like that, it'll always be just straight.
Yeah, exactly. Okay, what's the second thing you always have to do? Invariant points. Where do they happen? 1 and -1. So we look at y equals 1. There's 1 right there. We look at y equals -1. Stop. There is no y equals -1. So there's only one invariant point. That makes things hard. Because now we don't have x-intercepts. We only have 1 point. We only have 1 invariant point. So it's going to be hard to draw an accurate graph.
But they were really
Now if I look at this, I'm like, hey, there's an invariant point. My graph looks like this. Oh, it might also look like this. Right? It could also look like this. So when you only know 1 point, you're kind of screwed. So you got to come up with a new way. No dice. should show something. You have to come up with a new way to find new points. And they're pretty smart. You know, these people that create things, they know. Let's see if this works. Boom. They knew they only gave you 1 point that you could possibly find. They're not stupid, they're smart people. So they did something. They labeled a couple other points. In reality, they only had to give you 1 other point. They gave you 2 other points. So that's pretty nice. Go to one of those points. I'm going to go to 1, 1/4. And when I'm given a specific point, I can reciprocate it. So y was 1/4. What is y now? 4. So that point is now here. Go to the other point they gave you. 3 and 1/4. What's the reciprocal of that? 3 and 4. Now you've got 3 points. Now you can draw your graph. I said that there's only 1 point needed to be given to you. I said if they gave you just, if they gave you just this point, you'd be able to solve it. So we reciprocated that point. It gave us 4. Now we remember. You're close.
Oh, I see.
You have an axis of symmetry. You know that that's a vertex. If you look at it, you can just tell that has to be a vertex. Which means this has to be the same distance away over here. It's got to be 1 away. There's an invisible axis of symmetry that runs through your vertex of a graph. That's a little bit of a rewind refresher from 3 minutes.
I feel like this just goes better.
If what?
Like how it just like
Yeah. Yeah, you don't need to know that. That's why they gave you 2 points. They didn't want you to remember that. But I wanted to just bring it up because I know that our final's coming, so I want to kind of start getting little things of like, hey, remember. Yeah. I don't know, 24th or so, 25th. Okay. These ones should be quick now. So, try these 2 on your own. See if you get the same graph I get. You want to unreciprocate these graphs. Get the original function. If you got the same answer to me, that's awesome. I'm going to erase these. And I'm going to show you my process, how I did it. Okay, some people were looking at it first.
All grade 9 girls basketball players should now be down in the common area getting ready to leave for your game. Grade 9 girls basketball in the common area now.
So, if you look at this first graph, you want to do the same 3 steps. Your first step is asymptote, but now your asymptote tells you your x-intercept of the original function. So we mark it. Then you want to mark your invariant points. They're at y equals 1. Right there, right there. I think most people are doing pretty good with that. Once you have 3 dots, especially when one of the dots is a maximum point, you're good to go. Okay, this next one was a little more difficult, but we're going to follow the same steps. Step 1 is mark your asymptotes. Right here and right here. Those are going to be my x-intercepts of my graph. Step 2 is mark my invariant points. They happen at y equals 1 and y equals negative 1. Y equals 1 is right here, this line. And it crosses there and there. Y equals negative 1 is here and here. Yellow.
Draw this. You have to draw this.
I thought that's kind of what they had asked in a different form of a question. That's a good question. Will we have to do this and then make the equation? No. Pretty unlikely. Yeah. You're just going to be drawing these things for the most part. Cut.
So, what is y equals 1? Really
Where's y equal 1? Right here. Y-axis, y is equal to 1. So if you draw a straight line across, that's all the points that y equals 1. So if you go across, you run into the graph there, that's where y equals 1. You run across, that's where y equals 1. And the negative 1 works the same way. It comes down, that's where y equals negative 1. Go across till you hit the graph. Hit it, hit it. So those are my invariant points. Step 3 is reciprocate. But do your maximum or your minimum point first.
That's so weird.
I thought you were saying.
Take that point right there. That's going to be my maximum or my minimum.
He's not a character off the movie. Someone can point him. No, he's not.
Okay, back up here, because this is where you all were lost. That's going to give me a maximum or a minimum. That point right there. So what is that point? What's the y value? 1 over 2. It's 1/2. So what's the reciprocal of 1/2? 2. So now it's there.
Oh, I think like 0.5.
And there you go. Hi.
When I have this reciprocal arbitrary, either when you have how it has to be reciprocal, how it should be the opposite side here.
Yep.
Really simple.
If you look back at this graph, remember your asymptotes have cut this graph into sections. Section 1 was up here. Section 2 is in the middle. 3, 4, 5, 6. That asymptote in each spot should connect with a blue line in that spot. So we look in here, I have a function. It's been reciprocated. If I look in the middle, there was nothing in here, and there's still nothing in there, so that's a good sign. Over here, I had a red line, now I have a blue line. Top right corner, I had nothing, I still have nothing. Up here, I had a red line, I have a blue line. Up here, I had nothing, I still have nothing. So it's a good way to check to make sure you didn't make any mistakes.
Okay, so say like you would read it as 1/2, and this as 0.5.
That's a great question. Because most people see 0.5. They don't see 1/2. So if you have 0.5 and you get asked what's the reciprocal of 0.5, because that's what you were trying to figure out. It's 1 over 0.5. Punch that in your calculator. That's equal to 2. But just punch in your calculator and it'll tell you. Soccer.
So 0 and then 1 over 2. What if that 0 was and then 1 over 2? You reciprocate the 3.
You just reciprocate y values. Just y values.
So we're just going to find a graph and have to do both of them, or is it only
Depends on the question. But on your test, because remember your tests aren't written tests. They're multiple choice tests. So what you're likely to get is a graph like this. and then 4 other graphs that are the reciprocal, and you have to know which one is the reciprocal. So you're never going to have to draw things perfect, but you're going to have to know where points went and be able to draw it if you were asked to. So knowing how to draw it will make those things easy. Okay. 2 multiple choice questions, and then we're done. And they're not even multiple choice, they're multiple sections. Brutal. Just pick your desk up, move it right behind Starla. Yeah, it'll make my life so much easier, so I don't have to keep looking over at see you do things, or smacking him's butt, whatever you two are doing over there.
It's more like an anatomy class.
Oh, gee, Josh! Well done. Okay. 13. A reciprocal function has the form 1 over ax squared plus b. How can you determine the number of asymptotes of the graph of y equals 1 over ax squared plus b when both a and b are positive, when both a and b are negative, or when a and b have opposite signs? So here's what we're going to do. Do a graph. It's saying, draw that, and tell me how many vertical asymptotes there will be. But you don't know what A and B are. We can graph this. We know how to graph those. Those are easy. So, if both A and B are positive, A tells me it's going to be facing upwards, because it's positive, and B tells me that the y-intercept is going to be positive. So I'm going to start somewhere up here, and I'm going to be facing upwards. So how many asymptotes would I have?
0.
Now let's try it in red. So, I want to take my graph. Ax squared plus b. Both a and b are negative. If a is negative, I'm going to open down. If b is negative, I'm going to have a y-intercept of a negative. So it's going to be somewhere down here, and it's going to open down. How many y-intercepts do I have? Or x-intercepts? So how many asymptotes do I have?
0. Don't you always have the cross?
Yeah, I was gonna say.
You always have a horizontal asymptote. That's true, but it asks, just ask you vertical. Oh no, it doesn't. So yeah, it should have said vertical asymptotes. But good point. There's always the horizontal one.
So
Soccer.
it said how many horizontal asymptotes? What?
There'll always be one horizontal asymptote. Yeah.
You're wrong.
This question, because it just says number of asymptotes, there should be 1 and 1. It should have said vertical. That's what I was looking for.
If I was like writing tests, I had to draw them, and I couldn't draw writing or something like.
You won't have to ever draw on here, dude. No. Remember, it's multiple choice, right? So always multiple choice or numeric response. No more written. Yeah, we haven't done a written question in units now.
No, like, but like I'm quizzes.
Oh, quizzes we do, but we're not gonna have quizzes and stuff.
I'm so confused. I don't remember.
Finals all multiple choice numeric response.
There's no short answer calls.
Okay. C. I'm gonna do C in green. A and B have opposite signs. So there's 2 situations. Situation 1 is A is positive and B is negative. Situation 2 is situation 2 in black. Negative and positive. It's not the same thing. Yeah, that's why it's one question. So like the answer will be the same for both of them. That's why it's one question. Yeah, I don't know why it's there. So A is positive, what way are you opening up?
Upper.
But the B is negative, so where's my y-intercept? So I'm down here somewhere, and I'm opening upward. So how many y-intercepts do I have? Or x-intercepts? How many asymptotes do I have? Now, what if it's the other way around? You have a negative A. Which way are you opening up?
Down.
Downwards. You have a positive B. Where is your y-intercept? So it's up here somewhere. So how many asymptotes do you have? 2. So your answer for C would be 2 asymptotes. Yeah. The number of vertical asymptotes that the graph have if A and B were opposite sides. 2. And you could have figured it out. You could have figured it out either way. Do you see? Can you go shut the door for me, please?
Do you ever have like those ones that be like 1 or 3
Are you ever gonna have 3 vertical asymptotes? Not in this class. Not in this class. You're right. If you had a function that crossed 3 times, you would. Not in this class, though.
Once we get to they
It depends. If there's 2 lumps, it's called cubic. And then 5 lumps, something else. 6 lumps, 48. Which? A little bit. Okay. We're not done, and we're not leaving till I finish. And this next question is the longest one of all. Determine the values of k for which the reciprocal function has no vertical asymptotes, 1 vertical asymptote, or 0. So it's 2 vertical asymptotes. So you've got a function. It's asking you for how many vertical asymptotes there are. Vertical asymptotes are also just x-intercepts from this original question right there, before it was reciprocated. So really, this question says x squared plus kx plus 4. For what values of k will you have no x-intercepts? And you could pick a number, say 0, test it, see if it works. You would see if you put 0 in, you would have no x-intercepts. But the problem is they don't want to know odd number for k. They want to know all numbers for k. So they want to know every single number k could be that would give you 0 vertical asymptotes. Which means we need 0 x-intercepts. How do we figure out the number of x-intercepts something has without graphing it or without solving? Quad formula is close. The discriminant. The discriminant tells you how many x-intercepts something has. So the discriminant also tells you how many asymptotes something has. The discriminant will tell you the number of asymptotes.
Yeah, but like that's it.
Yeah, like it won't tell you. Remember when we did it? It told you the number of x-intercepts, but it didn't tell you where they were. Same thing, same idea. So it'll be like, oh, there's 2 vertical asymptotes. We have no idea where they are, but there's 2 of them somewhere.
That's
You're- Yeah, b squared minus 4ac. So for this question, you don't know a number. You don't know your b. What you do is you put k in for b. So your discriminant is k squared minus 4 times a times c is 16. That's 4 times 1 times 4. Right? So 4 times 4. We want no vertical asymptotes. So what do we want this number to be? Negative. So we want it to be less than 0. That tells me if I get a k value that would make this less than 0, then we're good. That would have no vertical asymptotes. If you look at that, you're going to add 16 to both sides, and you're going to square root it. Right? So add 16 to both sides, plus 16, plus 16, and you get k squared less than 16. So whenever k squared is less than 16, you're going to get 0 vertical asymptotes. So now you can square root both sides. I'm running out of room, so up here. K is less than positive or negative 4. Here's the tricky part to this. If you chose a number of k less than 4, it doesn't work. Negative 10 is less than negative 4, but that doesn't work. Negative 10 squared is 100. 100 is not less than 16. So there's a trick to these things. When you have a less than sign, and you have to multiply by a negative, what you did when you added this plus or negative, you have to flip the sign. So you're going to have k is less than 4 for the positive, but then k is greater than negative 4 for the negative side. So when k is in between negative 4 and 4, you could have 0 vertical asymptotes. And now you do it for this one. So for 1, and you do it for 2. But it actually is going to work out the opposite. So if you wanted 1 vertical asymptote, you would want k to be equal to 4 or negative 4. And if you want 2 asymptotes, you would do k is greater than 4 or less than negative 4. They'll switch around. Okay, put the next one.